Welcome to Physics 6.3a on waves and vibrations. Waves are absolutely everywhere around you. Here are just a few examples. So what is a wave? Well, a wave is a disturbance that travels through a medium from one location to another. It is the motion of the disturbance. If we use a slinky as an example, if it's stretched from one end to the other and held at rest, it assumes a natural position known as its equilibrium or rest position. To introduce a wave, we have to create a disturbance. We have to move the particles away from their rest position, and there are two ways to do this. One way to do this is to jerk the slinky forward. The beginning of the slinky moves away from its equilibrium position and then back, and the disturbance continues down the slinky. This disturbance that moves down the slinky is called a pulse. If we keep pulsing the slinky back and forth, we could get a repeating pattern.
In a longitudinal wave, the disturbance that makes up the wave is along the direction in which the wave travels. Longitudinal waves are also referred to as compression waves. In a transverse wave, the disturbance that makes up the wave is perpendicular to the direction in which the wave travels.
So this is an example of that longitudinal wave, right? The pulse transferred through the medium of the slinky, but the slinky itself doesn't actually move. It just displaces from its rest position and then returns to it. So what is really being transferred here? Well, energy. Energy is what's being transferred. The medium ends up in the same place that it started. It just gets disturbed and then returns. The wave we see is a longitudinal wave. The medium particles vibrate parallel to the motion of the pulse. It's the same type of wave used to transfer sound. So the anatomy of a longitudinal wave, the tight part is known as the compression. The loose part is known as a rarefaction, and the wavelength is measured from the same position in a compression to the corresponding position in the next compression, or it's going to contain one compression and one rarefaction. The second type of wave is known as a transverse wave. In a longitudinal wave, the pulse travels in a direction parallel to the disturbance. But in a transverse wave, the pulse travels perpendicular to the disturbance. And here's a typical transverse wave. In our wave, the dashed line represents the equilibrium or the medium, the rest position. Once the medium is disturbed, it moves away from its rest position and then returns to it. The crests are the top points of the wave. The troughs are the bottom points of the wave. The amplitude is the height and can be measured either from the medium up or the medium down. The wavelength is the distance between two consecutive points, in this case two crests, and its symbol is known as lambda. So the difference between the two types of waves can be seen. Longitudinal waves travel parallel and transport energy through compressions and rarefactions. Transverse waves travel perpendicular, and the energy is transferred through crests and troughs.
In a longitudinal wave, the disturbance that makes up the wave is along the direction in which the wave travels. Longitudinal waves are also referred to as compression waves. In a transverse wave, the disturbance that makes up the wave is perpendicular to the direction in which the wave travels.
Really wish we could be together to play with slinkies, but hopefully you'll be able to do that another time. Thanks for watching.